Hello and good day everyone. I am Qian and I wish to propose on a project on the development of an Arduino-based photometer for the detection of reactive rate 120 dye. The keyword for this project is Arduino, dyes, photometer, and self-development. And first and foremost, please allow me to introduce myself. My name is QIAN and this project is under supervision of Dr. Amy Shazwani of the QIAN, and I'm studying in the Faculty Science in Chemistry department in UTM JB. The problem statement of my study is the water pollution issue, which is dominated by the dye industry, and the determination of concentration of dye in textile effluent is necessary using benchtop instrument, and it is actually costly and may not be affordable by all industry. That's why I come up with a solution which is a self-developed photometer can be achieved at a lower cost. And this tool can be used as a screening tool to detect the dye concentration and at ppm level. There are two objectives of my study. The first is to develop an Arduino-based photometer using the LED as the light source. And the second is to determine and validate the concentration of reactive rate 120, which in short RR120, using the developed Arduino-based photometer. The methodology of my study can be divided into three, which the first part is the development of the Arduino-based photometer using a green LED. And the other components is also inexpensive and can actually easy to obtain, which is including the sensor module and Arduino Uno board. And after the development of the photometer, the analysis can be conducted using both developed photometer and also the UV-vis spectrophotometer. After the analysis run and obtain the data, a standard calibration curve will be obtained and to obtain the R-square value from each of them. The expected result also can divide into three, which the first one is a simple Arduino-based photometer can be developed successfully at a low cost. And the second part is the developed photometer is expected to have the detection at ppm level. The third is the R-square value obtained from the analysis using both UV-vis spectrophotometer and also self-developed photometer are expected to higher or equal than 0.995. And this figure 1 is about the schematic diagram of Arduino-based photometer, and this is a green LED which acts as a light source, which penetrate the light through the cuvette, which acts as a sample holder, and the light penetrate the cuvette will reach the sensor to be collected through the Arduino Uno by the computer. And the figure 2 is about the calibration curve, which is obtained from the trial analysis run using the UV-vis spectrophotometer. The R-square value will be improved in the next run and to obtain a value higher than 0.995. As a conclusion, a simple and low-cost Arduino-based photometer can be successfully developed for reactive rate 120 dye detection. And this developed photometer is expected to have the ability to detect and determine the concentration of dye at ppm level. These two are the two main references of my study, which the first part is about the dye pollution from the textile industry, and the second one is about the development of an Arduino-based photometer. And before I end my presentation, I wish to take this opportunity to thank UTM for funding through UTM Shine. Second, the Dr. Shahwati Muhammad Noor and Anis Shasha Halim are thanked for their guidance on the setup of Arduino photometer. And that's all from me. This is my email, and thank you for listening.